In this problem, it asks us to find the indicated probability. So a test consists of 10 true and false questions, and to pass the test, a student must answer at least 6 questions correctly. So I'm first of all going to look at what is the probability of answering one individual question correctly. Since it's true-false, that probability is 0.5. And we want to know if a student guesses on each question, what is the probability the student will pass the test. So we're looking for the probability of getting at least 6 correct. So this is the probability. If we look at the possible number correct you can get on this exam, it could be anything from 0 through 10. And we want to know the probability the person passes. That's the probability of from 6 to 10 successes. So when I try this on the calculator, it's not going to let me do this because it's starting at 6. The calculator only lets you calculate the cumulative probability starting at 0. So instead of doing probability of 6 to 10, what I'm going to do is I'm going to look at the opposite, which is 0 through 5. And I'm going to do 1 minus the probability of 0 to 5 successes, or correct answers. So when I do this in the calculator, this is going to be 1 minus binom CDF. It's CDF because we have a range of values. So the maximum number of successes we can have, or the number of trials I should say, is 10. Probability of an individual success is 0.5. And we want to have at most 5 successes. So when I put this into the calculator, I get 0.377, rounded to 3 places. And so C would be the correct answer there. Now let's take a look at question 53. So in this problem, it says that an airline estimates that 94% of people booked on their flights actually show up. So that's my probability of an individual success is 0.94. If the airline books 73 people on a flight for which the maximum number is 71, what is the probability that the number of people who show up will exceed the capacity of the plane? So we're looking at nobody at all could show up, 1 person, 2 people, and we get to 70, 71, 72, 73. So there were 73 people booked on the plane, and we want to know what is the probability that the number of people who show up is going to be a problem. Since the plane can only seat 71 people, we're looking for the probability of either 72 people showing up or 73. So to calculate this, we're looking at the probability of 72 to 73 successes, because this is binomial. And again, we're starting at a number not 0. So I'm going to turn this into 1 minus the probability of 0 to 71 successes. Keep in mind that you can't have those 2 groups overlapping. So we want the probability of either 72 or 73 successes. The calculator is going to calculate this from 0 to 71. So we're going to do 1 minus the probability of 0 to 71. And to enter that in the calculator, that's binom CDF. Number of trials is 73. Probability of an individual success is 0.94. And the maximum number of successes is 71. So when I put this into the calculator, I'm going to get 0.0618, and so that rounds to 0.062, and D is my answer. Okay, let's take a look at the next one. Here it says the participants in a television quiz show are picked from a large pool of applicants with approximately equal numbers of men and women. So we're going to say the probability of a selected person being a man is, well, let's see, what is it we're looking for? We're looking for a probability about women. So probability of selecting a woman should be 0.5 if that's approximately equal numbers. Among the last 11 participants, there have been only 2 women. We want to know what is the probability of getting 2 or fewer women when 11 people are picked. So again, I'm going to list out my possibilities. I don't have to list everything. So 0, 1, 2, 3, and then 9, 10, 11. And we want the probability of 2 or fewer, so that's going to be 0 to 2. We're already starting at 0, so this is good to put into the calculator. We're going to do binom CDF, because this is really probability of 0 to 2 successes. So it's a range of values. We're going to use binom CDF. Number of trials is 11. Probability of an individual success is 0.5. And we are looking at a maximum of 2 successes. So when I put that into the calculator, I get 0.033. Small probability, that would be B. And then for question 55, it says, in a survey of 300 college graduates, 56% reported that they entered a profession closely related to their college major. If 8 of those survey subjects are randomly selected without replacement for a follow-up survey, what is the probability that 3 of them entered a profession closely related to their college major? So here I'm a little suspicious because it says without replacement. But when I look at how many people there were in the survey, there were 300. So 300 participants, and if I multiply that by 5%, then I get 15. Since we surveyed fewer than 15, we only selected 8 of the survey subjects. So since we selected fewer than 15, that means we can treat this as if it is with replacement. So we don't care about it being without replacement. So we can use the binomial distribution for this. All right, so our number of trials, we are selecting 8 individuals. Probability of success is 56% for an individual. And we want to find the probability that 3 of them out of the 8 entered a profession closely related to their college major. So again, if I look at the possibilities, 0, 1, 2, 3, 4, 5, 6, 7, 8. In this case, I only want this one individual value. I want to know what is the probability of getting exactly 3. So that's when I'm going to use the binom PDF function, because we only have a single value there. It's not a range of values. So my number of trials is 8. Probability of success is 0.56. and the number of successes that I'm looking for is 3. So when I put this into the calculator, I get 0.162, and that's my final answer for that one. So that would be B. And that's how you do those problems.